the last activity is to basically replicate the same thing, but instead of the NAT instance, we're going to just use a NAT gateway. Let's look at the instances. So just to quickly recap, we have the NAT instance here. So that's what our private instance via route table connect and accessing internet through. Now we're going to take this off. Let's see what happens. So I'm terminating the NAT instance. Important to notice, VPC route tables. So in this configuration, this route table would still be pointing to a non-existent resource, a NAT instance, right? Let's look at what happens. You see, if we try the same thing here now, it won't work. And for obvious reason, because it's not connected to internet. So the route cannot be resolved. Previously, the traffic would have just dropped here, but now it just goes into an infinite loop. I just wanted to point that to you. Again, sometimes when we move things around, when you remove things around, we forget to remove the routes, and that can lead to performance degradation, sometimes network troubleshooting issues, and so on. So it's important to remove or update all the associated routes. So let's remove that for the time being. Okay, I think we touched upon what a NAT gateway is and how magnificent they are. So they're AWS managed service. They got a lot of benefits. So let's create one NAT gateways. So let's create one. The subnet it should be placed in is the public subnet. Yep. So here it mandates me to create an elastic IP. If I already have an elastic IP reserved within AWS for other purposes, or I have an allocation somehow, I can use them here, or I can allocate one straight away. Let's add a tag. So the thing with NAT gateway is sometimes it could take 10 to 15 minutes to get provisioned. And can someone tell me what is the last bit we need to do now? So we need to point previously where we were pointing the NAT instance. Instead, we are just pointing to the NAT gateway. So we'll go into the route table. So that's the private route table here. Routes. So as you can see, it's only still pointing to the internal traffic. We'll add what we did before. I don't know whether it's going to show up. Let's see. So I think it's still getting provisioned, but it showed up. Let's see if it gets picked up. So we need to select the NAT gateway from the available one. So we only have one. So I just picked up. Save routes. Let's see if it is still getting provisioned. Status is pending. So I think until that gets fully provisioned, the internet connectivity will not be there. But in a sense, it's the same principle. All we have done is replace the NAT instance with the NAT gateway here. And NAT gateway comes with certain benefits, being an AWS managed service. I think we got the NAT gateway provisioned, so now it's pinging again, even though the status shows pending. Okay, available. We're lucky.
Prakash, just like NAT instance, say if there is some problem and if it goes down, even with the NAT gateway, there will be the same problem. It's like a single, we need to deploy it in multiple AZs for availability, isn't it?
So that's why this is key. AWS takes care of we wouldn't, when we launched the NAT gateway, did you get any screen where you define where the availability zone going to be?
No.
So that's the advantage of using gateway, because AWS takes care of all of that for us.
And when we do this auto scaling, yeah, we do the increase and decrease of the servers.
Yeah.
So where does that exactly, this auto scaling and the elastic load balancers sit in that VPC?
So VPC is something more static in that sense. So you have created a network, right? So you are, unless you are completely creating a new network within which you are placing a resource. Say, I'll give you an example. So you're running a website, you're expecting a traffic spike on a particular day, and you have designed your infrastructure to anticipate the traffic. Suddenly the traffic has gone twofold more than you expected. How can we handle? So given the cloud native characteristics, a lot of things can come into play. One of them is what you mentioned, auto scaling, right? So when it comes to scaling, are we going to create more number of servers, for example, or are we within the same network, or are we going to create new subnets within which either you're going to move your existing instance for load balancing purposes or create more instances? It's all depend on how you are defining your auto scaling. So that's scaling groups and the placement groups for the load balancer.
So what's the general suggested solution? I mean, if in that case, is it good to increase the instances in the same subnet, or is it good to increase?
So if you look at this diagram, you have to look at the bottlenecks, right? So for example, you have one subnet, you already have 5 instances. There is a significant network throughput already going through this. By adding 5 more instances, it's not really going to help your case because you only have one gateway here, and that's going to struggle even more. In that case, it would be useful to create another subnet, allocate a gateway there, and either move some instance here or provision a set of new instances where you can share the load via 2 different gateways, where you could achieve much better performance. Again, it really depends upon the scenario. This is just one example.
When you said creating another VPC, it is not a more manual work?
Now, through script, you can do that.
Oh, okay.
So everything that we are doing here, we can do as script. So one of the things I was looking to do in the next session is we can create the VPC via command line interface, CLI. So I'll show you how to create a VPC through command next session.